kinematics. We know that physics is an experimental science. It is based on experiments and observations. And we'll do calculations for the experiments using mathematics. 2000 years ago, a Greek librarian, Eratosthenes, measured the radius of Earth, okay, using ordinary mathematical calculation. But the size of the atom was measured only in 20th century. So the entire universe here, if you take the entire universe, it is governed by various types of motion. So we can take the motion at all levels, that is microscopic level as well as macroscopic level. Microscopic in the sense with small range, that is the motion of an atom. Macroscopic in the sense with a larger range, okay, and galactic level also, that is in planetary system and beyond, okay. So in the whole universe, if you take, motion is taking place at all levels. To study the various types of motion, we need the language of what? Mathematics. So the basic mathematics needed for analyzing motion in terms of its direction and magnitude. So when we are learning the motion, we need to find it out in which direction the body is moving and what is the magnitude value of the direction. Okay. So that is very important in studying what? Motion. So now here we are going to study the definition for kinematics. Kinematics is nothing but a branch of mechanics which deals with motion of bodies without taking force into content. Actually, mechanics will be divided into two as kinematics and kinetics. Both are dealing with the motion of the objects only, but kinematics is the one without taking the force into account, but kinetics is the one with taking the force into account. Okay. So here we are going to study only about the kinematics. So from where we got the name kinema? That is, kinema means what? Motion. Now in kinematics, we have to go for two important concepts, that is rest and motion. Okay. Now here is an example. If you see, take a person sitting in a moving bus. Okay. For the fellow passenger in the bus, the person is at rest. But for a person who is outside the bus, the person is in motion. Okay. So the concept of rest and motion have meaning only with respect to the frame of reference. So for the person who is inside the bus, the fellow passenger is at rest. So the frame of reference is the bus itself. The person who is outside the bus, the person is in the bus is at motion. So the frame of reference here is the outside platform or something else. Okay. So the concept of rest and motion have meaning only with respect to that of what? Frame of reference. Okay. So here is the picture which is showing what? The frame of reference. Now we should know what is frame of reference. If the position of the object is described related to a coordinate system, then such coordinate system is called as what? Frame of reference. So if you are describing any object with respect to that of what? Any coordinate system, we call it as what? Frame of reference. Now, one of the most common coordinate system is a Cartesian coordinate system. So how to define Cartesian coordinate system? At any given instant of time, the frame of reference with respect to which the position of the object is described in terms of position coordinates. So that is along x-axis, y-axis and z-axis. Then we call it as what? Cartesian coordinate system. Okay. For a given time, the frame of a frame of reference with respect to which the position of the object is described. If you are describing in terms of x-axis, z-axis, and y-axis, then we call it as what? Cartesian coordinate system. Now this diagram is telling you the Cartesian coordinate system. Now you can take, we have taken x, y, and z coordinates. Now the point here is representing x, y, z. So this is the position of the object. This is the position of the object. The blue line gives the x coordinate, and the red line gives the y coordinate, and the green line is giving you the z coordinate of the position of this object. Now we have to go for the right-handed coordinate system. Now if the axis of drawn in anti-clockwise direction, x, y, and z are drawn in what? Anti-clockwise direction, like this here. You can see it is x, y, and z. Then we call it as what? We call it as right-hand coordinate system. We call it as what? Right-hand coordinate system. So most of the time in physics, we'll follow the right-hand coordinate system. Okay. Now, how to explain the right-hand coordinate system? Place your fingers in the direction of positive x-axis. Rotate them towards the direction of y-axis. Your thumb will point in the direction of what? Z-axis. Okay. We are placing the fingers in the direction of the positive x-axis and rotate them towards the direction of what? Y-axis. Then the thumb will give you the direction of what? Positive Z-axis. Now, what is the difference between the right hand and left hand coordinate system? In the right hand coordinate system, okay, you will be drawing the coordinates in the anti-clockwise direction. In the left hand coordinate system, what will it? We will be drawing in the clockwise direction. We'll be drawing in what? Clockwise direction. You can see in the first diagram, here we have the Z up, that is Z coordinate up. And here it is in anti-clockwise direction, x, y, z. In this diagram, you can take it. Here it is in clockwise direction, x, y, z. Here also what is z is up. Now this diagram is having what? Y is up. Here x, y, z. It is in anti-clockwise. Here also y is up, but it is in clockwise direction. Okay, x, y, z. Okay. Now here we have to go for an important term called as point mass. Okay. What is a point mass? That is mass of any object we assume to be concentrated at a point. We are assuming a mass at a point. Okay. This is an idealized mass. So actually there is no such mass. Okay. So only we call it as an idealized mass. So this mass we call it as what? Point mass. This mass is having no internal structure as size and shape. So you can say point mass as finite mass with zero dimension. It is having a finite mass with what? Zero dimension. Actually, it does not exist. Why we are considering this is in order to simplify our calculations. In order to what? Simplify our calculation, we are considering our point mass. Okay. So the point mass term is a relative term. It has meaning only with respect to a frame of reference and with respect to the motion of the object. Okay. Here you can have two examples. So in order to analyze the motion of the earth with respect to sun, we are treating earth as a point mass because the distance between the earth and the sun is very, very large compared to the size of the earth. Okay. So sun is a frame of reference. So we are treating what? Earth as a point mass. Another example, if we throw an irregular object like a small stone into the air, then to analyze its motion, it is simpler to calculate the stone as what? Point mass and its motion in space. So the size of the stone is very, very smaller when we compare to that of the distance which it is traveling. Okay. So this is how we are explaining the point mass. So in this video, we have learned about what is kinematics, what is rest, what is motion, what is frame of reference, and what is a point mass. Okay, so these are some of the important concepts which we should know in studying the kinematics. Okay, to study the motion of the object, these terms are very, very important.